Well, hello there. This is Dr. Dell, and this is what I'm going to call Ethan's message number 2. And in message number 1, one of our students named Ethan asked me the question on how to solve this problem. And that is, if you've got this kind of a drawing here, a circle with this triangle, and this is angle X, and this is length L for this hypotenuse, what's the area of the circle? And I answered that in message 1, and I showed you that if X was either 30 degrees or 45 or 60, you could do it with geometry, but if X was on some other angle, you had to use trigonometry, and I explained that, and you might want to go back and watch that for for the message number 1. And when I say Ethan, that's a generic name. It could be Sally. It's any student that might be interested in STEM math, and I want to expand on what I discussed back then and talk about that now for anybody that thinks they even might remotely be interested in science and engineering. And so what we're going to do is we're going to take this right triangle, and this has length L, that's the hypotenuse, and this is an angle X. Then, as I pointed out in that first video, this length right here is L times the cosine of angle X. I'll just say cosine of X. And this side, I didn't tell you in that video, is L times what's called the sine of angle X. Now, angle X is going to be measured in, when we get on into modern math, in what's called radian measure, not degrees. And that'll be explained to you in Tier 4. So all of this is essentially now what we talked about in the first video. And then I'll point out to you that by the Pythagorean theorem, since this is a right triangle, you have that if you take the base here, this base, L times the cosine of angle X, and if you square it, and then you add that to the other side, L times the sine of angle X, and that's squared, by the Pythagorean theorem, that will equal L squared. And you use a little algebra, and you factor out L squared, and you're left what's inside here with the cosine of X squared plus the sine of X squared. And now you can divide both sides by L squared, and you'll end up then with what's inside here. Cosine squared plus sine squared is equal to 1. And that is a trigonometric identity. That's what we call it, because that is true for any angle X. And that's something we discussed near the end of Tier 4, where we're talking all about functions and graphs and things of that nature, and we end up talking about trigonometric identities. So this is climbing a ladder. First you learn about sine and cosine in practical math and how to solve some practical problems like this one here that we gave for Ethan. And then we expand that into talking about the function sine of X, and we learn to graph it. And so if you take a graph for sine of X, and this represents angle here, the graph of the sine of X looks like this, and it goes on indefinitely. This is the x-axis, this is the y-axis, and this would be the graph of the function y equals sine of X. And as I said, we won't be measuring angles in degrees now, we'll be measuring them in radians, and we explain that, of course, in Tier 4. And I might add, you can do calculation with your calculator. If you take the TI-30XA and hit the second degree key, it'll convert to radians, and all of a sudden you can deal in radians. And that's all explained in Tier 4. Radians is a more natural way to measure angles. Now, what we have then is we have in Tier 4, we graph functions, and this is the function y equals X. Now, historically, graphing function was very time-consuming and painful, but we use something today, as I told you in the previous message, Wolfram Alpha. And Wolfram Alpha now will graph any function for you immediately and accurately and tell you everything you want to know about the graph, and that's absolutely wonderful. It reduces the amount of time it takes to learn about functions by looking at their graphs by an order of magnitude or greater. Maybe it used to take you, half an hour to graph a function. Now it takes you 30 seconds with Wolfram Alpha. And so you can do lots more examples, and you can solve a lot more problems with Wolfram Alpha. It's a wonderful tool. And by the way, that tool was not available to the world until 2009. Things that took me a year to learn, you can learn now in a month because of this tool. Now, after we learn about identities and graphing functions, the next thing we want to do is we want to learn how to analyze a graph of a function, and for that we need what's called calculus. So let me start out, and let's take a point on this graph, and let's say this comes from x, so this is the point sine of x for a particular x, and we want to look at the tangent line and look at its slope. Now in Tier 4 we talk about straight lines and their slope, and the slope, it just measures how rapidly they're either descending or rising. It would be a negative slope. If you had a positive line over here, this would be a positive slope. Now the question is, what's the slope of that tangent line? Now you're getting into what is called differential calculus. You take dy by dx, and that's called the derivative of the function y with respect to x. And what would that be for this particular x value right here? What would be the slope of that line? Well, it turns out we demonstrate that that is, believe it or not, the cosine of x. And so now, bingo, we are now taking what we know about functions, in this example, a trig function, and we're looking at its derivative, which lets you know about the slope of these lines, and that lets you find the maximum points, the minimum points, points of inflection, all sorts of things of that nature. This is called differential calculus. And now, once you've got dy dx equals cosine of x, you can define something called the antiderivative, and that would be the antiderivative of the cosine of x dx is sine of x. Usually you say plus a constant because the derivative of a constant is 0. So once you know what a derivative is, you can calculate, you can figure its antiderivative. This is all done in what's called differential calculus. And now we're getting into what we call integral calculus, and here's why. What if you wanted to know the area? Let's take a point here A, and another point over here B, and you want to know the area under this function curve from A to B, under the sine curve. Well, that would be very, very difficult to calculate. Our ancestors really struggled with this problem, but it turns out that if you can find an antiderivative of the sine function, if you can find one, then it's going to be easy to do. You're going to put in A here and B here. Now, what do you suppose would be the antiderivative of the sine function? Well, you might guess that it's the cosine function, and you'd be close. It's actually minus the cosine function. So this would be minus the cosine of the point B, minus, and then another minus the cosine of the point A, and that would be the answer to this area. Now, this was called the fundamental theorem of calculus, and you learn this now in what we call integral calculus. Calculus is divided into two parts. There's differential calculus, where you learn to find the derivatives, and once you've got derivatives, then you can find antiderivatives, and then you use that and apply the fundamental theorem to calculate areas. This is a really big deal. The fundamental theorem of calculus was probably the most important theorem in the history of mathematics because it's what opened up the field then of modern science. Isaac Newton discovered the fundamental theorem and applied it to physics to create what is called Newtonian mechanics, Newtonian physics. The models that we then use to calculate the orbits of planets around the sun, for example, and the orbit of the moon, things of that nature. And integral calculus then was invented back in the late 1600s and carried forward, and it's the basis now and used and throughout science and engineering and technology. And we cover that in Tier 5, the second part of Tier 5. Now, historically, this was very difficult because we had to do a lot of things manually. Wolfram Alpha makes it automatic and easy to do very, very easily. Now, I'll tell you one more thing. This right here is called a differential equation. Dy dx equals cosine of x, And the question is, if you didn't know, what's the function that solves this differential equation? Of course, we know it's y equals sine x, because that's how we got that equation. So this is very easy to solve, but that's called a differential equation, and there are many more like it, and that's what we cover in Tier 6. Because what you do in science and engineering is you set up models of something you're studying, and usually the model you set up is a differential equation. Then you have to solve it. Historically, that's been extremely challenging with manual tools. Today with Wolfram Alpha, it's extremely easy. So calculus has gone from a difficulty, differential calculus on a scale of 1 to 10 in difficulty before Wolfram Alpha was probably a 6, and most people could get through it. Then integral calculus was probably an 8, and that really, in fact, I should say differential calculus was probably more like a 4 or 5. And most students would get through that. When I was teaching engineering school long before Wolfram Alpha, most students could get through differential calculus. Then to integral calculus, finding antiderivatives is much, much harder. And that would be on a scale of 1 to 10 and 8. And that probably flunked more students out of science and engineering, STEM studies, than anything else. It was a big barrier. Well, that barrier is gone now, thanks to Wolfram Alpha. Today, if you want to know the antiderivative of any function, Wolfram Alpha gives it to you almost immediately. And you don't need the manual tools. Then after that came differential equations, and that was even harder. That was probably a 9 on a scale of 1 to 10, and today it's back down to a 1 or a 2 because of Wolfram Alpha. Now, the point I make, and we do that in Tier 6. So today, when I studied this before Wolfram Alpha and even before calculators came along, it was very burdensome to get through this, and it took a long time and a lot of effort and a lot of perseverance. And I will tell you that I consider myself not very much above average in mathematics ability. There were a lot of students that had much more ability in math than I did. They could learn quicker, they could do problems quicker, but it was very arduous and time consuming, and so they would tend to drop out, and I hung in there for years and years and years. And from the time I began to study these subjects, when I was like 15 years old, 14 and 15, until I finally mastered the things I'm telling you now, I was in my early 20s. And so it was many, many years of arduous work. Now today, because of the tool Wolfram Alpha, you can start when you're, say, 12 or 13 years old, 14 years old, and in a matter of 2 or 3 years, you can be all the way through differential equations. And it's not that hard to do. It's an order of magnitude easier than it was prior to that. So if you are interested in science and engineering, which is the basis of STEM, science and engineering, S is science, E is engineering, T is technology, if you're interested in those things, you're going to need to learn math up through differential equations. And it's easy to do today. And we do that in our 6-tier program. Now, I'm going to tell you, the one reason I'm telling you this is an overview. I'm not really teaching you math now. I'm just trying to give you a feeling for what it takes, what you're going to be involved in climbing the ladder. And the analogy I like to use, one analogy, is suppose that you are faced with a jungle and you need to go through a long stretch of jungle to get from one side to the other. You're over on this side, and on the other side is a wonderful lake you want to get to, but there's a jungle in between. Well, if you just head off into the jungle with, say, nothing more than a machete, that's very terrifying. And in fact, there's a good chance you're going to get lost. There's a good chance you're going to give up. There's even a chance you're going to die. That's what mathematics used to be like a jungle. Well, then tools started coming along. Suppose you had a path through that jungle. Someone had made a path. Well, then it would be much easier. You could just follow the path. But let's say you had to walk. Well, it's still going to be a long, arduous trip to get through a rather long jungle. But suppose today that you had a motorcycle you could ride on that path. Then you could go through the jungle very quick and very easy. Well, what we do now is we create the path for you, and Wolfram Alpha is the motorcycle for that path. And so if you're interested and you think you might be interested in science and engineering, then this is the way you want to go. Now, one reason I'm telling you this is if you look at math books today, you go to the library, or maybe you have some, and you look at the math books, they tend to be several hundred pages long. You've got an algebra book, analytical geometry book, calculus book, maybe a differential equations book if you've gotten that far. And these books are hundreds of pages long, and you look at that and you say, I can never do that. That's like this huge jungle. I have no idea what I'm getting myself into. Well, they're obsolete. Because they're full of all the old manual tools you're never going to use. So it's almost like you're going to have to go through the jungle with a machete, like our ancestors did. Those manual tools are like a machete. Well, today we have Wolfram Alpha, and I also then create the path for you. So today, with modern tools and with training, and by the way, there are no books that do this. I do this with videos that you can control and self-paced, with notes that go with them, and with exercises, because there is no book that does this that I'm aware of. If there is, let me know. And we lead you through this now so that you can go through the math you're going to need very quick. If you start out when you're 12 or 13 years old, you can be all the way through differential equations by the time you're 16 or 17. And you'll know it better than anybody that's gone through it the old manual way, because you will not have gotten lost. With the old manual way, you just, sometimes you can't even see what it's about because you're so tied up in the brush, as it were. And so that's what I wanted to tell you. I wanted to give you this overview. I'm not particularly talented at math, like I said, but I just stuck to it and went through it. One reason was I didn't really have any skills in anything else. For example, I wasn't very good at athletics. I thought once, well, maybe I'll try running cross country. And I went out and ran for the team, and I got to where I could do 4 miles in 26 minutes. Now, not very many people can do that. By most people's standards, that's very good. But it's not good enough to make the team. You had to run it in 21 or 22 minutes. And 26 was my best time for 4 miles. Wrestling, same thing. I got pretty good at wrestling compared to most people, but I wasn't good enough to make the team. And so on. And so I'm not any good at music. Mediocre at music. I'm not any good at art. I'm colorblind. Mediocre at that. Reasonably good at English. I can read pretty well. In fact, I majored in English and math when I was in college. But the real truth of the matter is I stuck to it. It's perseverance. And today, because it's so much easier, you don't need to study this stuff for 10 years like I did. When I started, let's say when I was 13 or 14 with, say, algebra, freshman in high school, it was at least 10 years before I got to where I'm telling you now. I was in my early 20s before I got to the point where I understood the things I'm telling you, but I had to do it all manually. Well, you don't have to do that. And that's what I want you to know. This video is to inspire you to realize that today, with the modern tools, it's much easier. So if you want to study physics or chemistry or biology or mechanical or electrical engineering, any of these things, the math is a universal language. It's the tool you're going to have to master. You can't master these technical subjects without mastering the mathematics. It's the tool. It's the language. But with the modern tool of Wolfram Alpha, and with a training program like mine, there may be others that are just as good or better. I don't know. I don't know of any. But if you go to my 6-tier program, you're going to go through this in a matter of maybe 3 or 4 years, very easily. And it's enjoyable. You're going to maybe work 5-6 hours a week, and you're not going to have to be obsessed by it. And like I said, I was average in ability. I've had a lot of students over the years that are smarter than I am, but it's perseverance. So I'm going to say that most students can do this now, and it's just a matter of putting your mind to it and persevering. And if you'll work, 5-6 hours a week, matter of a few years, you'll be through this with this modern tool. So this is Dr. Dale. I wanted to say this, sort of give you the overview, show you where you were going, what's involved in it, why you can do it, why you should not be intimidated. Let yourself go. Don't let some book scare you. And by the way, if you sit in on some math class somewhere, and if it's taught the traditional way, and they're still being taught that way, believe me, you can get snowed under real fast. I mean, I've watched some YouTube videos of calculus courses being taught by excellent professors, but it was the old-fashioned way of doing it, and they're challenging and confusing. This is going to be easy. You're going to love it. So this is Dr. Dell. I hope this has been helpful for you, and I will hopefully see you on some other videos as you're studying math and getting yourself ready for science and engineering, at least the possibilities of it. Hope you're having a great life. See you on another video.